All right, so now let's take a look at a probability tree diagram question. And this is just really spicy conditional probability, but in the same way that the rules of probability come from our two-way table, our conditional probability rules come from probability tree diagrams. So let's take a look here. Many employers require prospective employees to take a drug test. A positive test result on this test indicates that prospective employees uses illegal drugs. However, not all people who test positive actually use drugs. Suppose that 4% of prospective employees use drugs, and the false positive rate is 5%, and the false negative rate is 10%. So we're going to start off by making our two decisions here. So let's let D be that the employee uses drugs, and we'll let event T be that they test positive. Okay, so our first branch here is that they either use drugs or they do not use drugs. And we estimate that about 4% actually use drugs, which by the complement rule, 96% do not use drugs. Then we're going to go to the next case. So our first case there is that they use drugs. The next one is that they test positive and they use drugs, or they do not test positive and they use drugs. They test positive given that they do not use drugs, or they do not test positive given that they do not use drugs. So each of these is a different pathway. They test positive given they use drugs, or down here, they do not test positive given they do not use drugs. So here we're told that the false positive rate. So if this is the false positive, this means they actually do not use drugs, but they test positive. That is going to be 5%, which again, by the complement rule, this will be 95%. And here, the false negative rate, meaning they actually use drugs, but they do not test positive, is going to be 0.1, which means the probability that they test positive, given that they actually use drugs, is about 90%. So these are my branches here. And I have all sorts of different pathways I can take to get their intersectional probabilities. So remember, the general multiplication rule says the following. If I want the intersection of two events, well, then I just take the conditional probability and multiply it by the condition. So let's take a look at some questions we might see here. So the first step, and it's not really a required step, but it's drawing out the tree diagram, and now we'll actually do some math to it. So here it says, what percent of people test positive and use illegal drugs? So they test positive and they use drugs. Well, again, by the general multiplication rule, or by the branches, the probability that they test positive given they use drugs multiplied by the probability that they use drugs will help us find this probability that they test positive and they use drugs. So for us, probability that you test positive given that you use drugs is 0.9. And the probability that you use drugs is about 0.04, meaning that our probability here of having both of these occur is about 0.036 or 3.6%. And again, so that was just taking this part here comes from this top branch. So I guess I shall highlight that for us. That is this branch here. Now, the next question tells us what percent of people test positive? And so for this one, you're thinking, well, we just found that 3.6% of people test positive. Well, what we actually found was that they test positive and they use drugs. Now let's look at our four pathways here. We've already identified one of them, but looking at the remaining three pathways, one of these other pathways does include the probability of testing positive. And that would be this pathway here, that you test positive given you do not use drugs, because there's two ways to test positive, right? And so adding those together will give me the total probability rule. And just thinking about that, this comes from our two-way table example. Remember, when I break these events up, here's event A naught, B, and B naught. Event A is made up of B and B naught. So you can see there's two half probabilities to that total probability. So for us here, the probability of testing positive can happen one of two ways. So the probability you test positive can occur if you test positive given you use drugs, and you have to be using drugs first, plus the probability that you test positive given you do not use drugs, assuming you do not use drugs here. Well, we already found this first branch here. That was the 0.036. Plus the next branch here would be that there's a 5% chance that you're going to test positive given you do not use drugs, right? We call that the false positive. The probability of not using drugs is about 0.96. So the probability that you test positive is going to be roughly about 0.084 or 8.4%. So I just got that by summing up the two ways that I could test positive from this probability tree. Now notice here, I've got an intersection and I've got a total. This sounds a lot like both over a condition. So let's see what part C is going to reveal to us. And lo and behold, what percent of people use illegal drugs given that they test positive? And you might be thinking to yourself, wait, don't we already have this? No, we don't. We have the probability that they test positive given that they use drugs. But here we want the probability they use drugs given that they test positive. So here what we're going to do is, again, in my numerator, I will have the both. So I want that they test positive and they use drugs divided by the condition of testing positive. Well, on the AP exam, most times these are often scaffolded, meaning you've already found something that you need in part A to use in part B. So here we found their intersectional probability. That was 0.036. And then the total probability of testing positive was 0.084, meaning that the probability of using drugs given that you test positive is roughly about 0.4286. So almost a 50% chance that if you're using drugs given you test positive. And this could have been any other variation and it just would have been different steps. But essentially you just have to be prepared to navigate that probability tree diagram to find these different components. And so as you saw here, the only rule that you technically need is what we call here the general multiplication rule. This is how we find the intersectional probabilities when we have these given situations or these dependent situations. So what I need you to do now is go to the next page, and I need you to try out this example that is related to major storms. And there's a few scaffolding questions there for you, so go ahead and look at this one. But as a reminder, when we look at conditional probability, A given B means both over the condition. And this bar here means the if, given, or assume. Whereas for probability tree diagrams, we are just multiplying along the branches to find their intersections. And then if I add a full branch, I'll get a total probability. So that's just a little bit more info for you, some examples, but what I need you to do now is pause the video, try this out, and then we'll come back together to review the questions. So go ahead and pause. Alrighty, so here we are with tropical storms. I let A be Atlantic, E be Eastern Pacific, and W be Western Pacific, M be major. I just read all of my descriptors here, and I know the example we worked with only had 2 outcomes, but it could be something like this where you have 3 separate outcomes. So Atlantic, the Eastern and Western, notice again by the complement rule, they all still add up to 1. And then here, if it's in the Atlantic, it's either major or not major. Same goes for Eastern and same goes for Western. So really, here in the first question, to find all the ways it could be major, I am just going to take Atlantic in major, Eastern in major, Western in major. So the 3 different branches that will give me the total probability of being a major storm. And that should have been about 0.21. And then here at the bottom, it says given that it's major, so that's going to be the bar and then our condition, so that'll be our denominator. What is probability it's from the Atlantic? So then we have this here. And you could have found any of them, right? So for example, you could have also found the probability it's Eastern and major, or the probability that it's Western and major. Western given that it's major. And so that the only thing that changes is not our condition, because we're all looking at it if it's major, but what's in the numerator, what is the intersection? And so it could have been any one of those variations. And I'm going to tell you, for my test at least, you need to be prepared to find all of them. I've got multiple AP Stats section, so you're all going to have completely different tests, which is great because what an opportunity to learn. But now we've talked about rules of probability, simulations, conditional probability, and probability tree diagrams. So we have a pretty good foundation of what happens in this realm of probability. And in our last couple of lessons for this first half of Unit 4, we're going to look at special types of probability. And we're going to need to reference conditional probability when we come back to this. So up until this point now, you can do plenty of things here. But this is just the overview of probability tree diagrams. You multiply along the branches to find the intersectional probabilities, and then you add those branches to find total probabilities. And notice here that you have A and B, so now what you can do is you can make a two-way table from your probability tree diagram. I don't think they're going to ask you that, but you just never know with AP Stats. But stay tuned in our next lesson when we start talking about mutually exclusive events and independent events.